You know, our whole world, everything, from the car you drive to the power plant that lights up your home, it all runs on machines. But what keeps those machines running? Well, today, we're diving into the hidden science of something we pretty much all take for granted: industrial lubrication. It's the unsung hero, working silently inside every single gear, bearing, and piston.
And right away, this quote from ExxonMobil gets to this huge paradox at the heart of it all. Think about this. Lubricants are less than 0.5% of a plant's budget. It's a tiny, tiny fraction. And yet, when things go wrong with it, it can be responsible for almost a third of the entire maintenance bill.
So that's the big question for this whole explainer, right? How can something so cheap, so seemingly insignificant, be the root cause of some of the most catastrophically expensive failures? Well, to answer that, we need to kind of peel back the layers on what's really happening when a machine breaks down. And we're talking about a massive issue here. It all boils down to one thing: premature machine failure. We're not talking about machines just getting old and wearing out. Nope, we're talking about them failing way, way sooner than they ever should.
Okay, check this out. This is called the PF curve, and it basically shows the timeline of a failure. It all starts at point P, where some hidden defect gets introduced, but the machine, it seems to be running just fine. As we move along, we hit a zone where fancy predictive tools can actually spot the problem. But if you miss it, you get to point F. That's when things get obvious. You might hear a weird noise or feel it getting hot. And from there, it's a quick trip to total failure. The key thing to get here is that the real fight is won or lost way back at the beginning, in that early silent zone, long before anything actually breaks.
To really understand that root cause, we need to zoom in. I mean, way in. We're talking down to the microscopic level, where there is a constant, invisible battle being fought inside every single machine. And lubrication, that's our main weapon in this fight.
The basic definition seems simple enough, right? Lubrication is just putting some stuff between moving parts to cut down on friction. But, oh, its job is so much more complex than just making things slippery.
A modern lubricant is an absolute multitasking marvel. I mean, yes, of course, it reduces friction and controls wear, but it also has to prevent corrosion, it has to carry away nasty contaminants, remove heat to keep things cool, and in some systems like hydraulics, it's actually transmitting power. It is literally the lifeblood of the machine. The best way to picture this is to think of a car hydroplaning on a really wet road. The tires aren't on the pavement anymore, they're floating on a thin film of water. That is exactly what good lubrication does. It creates this thing called a hydrodynamic film of oil that completely separates the metal surfaces. So get this, in a perfectly lubricated machine, the moving metal parts never actually touch. Wild, right?
So if the whole goal is keeping those metal surfaces apart, what's the biggest threat? It's the enemy from within: contamination. We're talking about microscopic little particles of dirt, dust, and wear debris that get into the lubricant and turn it from a protector into an attacker.
To really get a sense of how big this threat is, let's start with something we all know: 1 single teaspoon.
And here's where it gets crazy. Just 1 teaspoon of dirt, that's it, mixed into a 55-gallon drum of clean oil, introduces about 1 billion damaging particles. A billion tiny little wrecking balls just circulating through your machine, ready to cause havoc.
And just how small are we talking? Well, a human hair is about 70 microns wide. But look at the critical gaps inside machinery, the space the oil has to protect. In a super high-precision servo valve, it's just 1 to 2 microns. So the very particles causing the most destruction are completely invisible to us.
And what this creates is a destructive process with a cool scientific name: 3-body abrasion. But it's actually pretty simple. It's when a hard particle gets trapped between 2 moving surfaces and just acts like sandpaper, grinding, scratching, and gouging away at the metal. And worse, that creates even more wear particles. It's a vicious chain reaction of destruction that all starts with a single invisible speck of dust.
So, how in the world do you fight an invisible enemy? Well, you stop trying to put out fires, and you start building a fortress. You shift to a proactive defense.
This really comes down to 2 totally different ways of thinking about maintenance. You've got the old school, reactive way. Wait for something to break, then rush to go fix it. It's disruptive, it's expensive. The proactive philosophy is the exact opposite. It's all about eliminating the root cause of the failure, like contamination, before it ever gets a chance to do any damage.
And the strategy is built on 3 really simple pillars. First, you set cleanliness targets. You actually define how clean the oil needs to be for each machine. Second, you exclude contaminants. You use high-quality seals and breathers to stop dirt and moisture from ever getting in the first place.
And third, you actively remove any particles that do manage to sneak in using super high-efficiency filtration.
Now, a huge part of any proactive defense is gathering intelligence, right? You need a way to know what's going on inside your lubricant and inside your machine, and that's where oil analysis comes in.
Honestly, this analogy just nails it. Just like a doctor takes a blood sample to check on your health, an engineer takes a tiny oil sample. And that little bit of fluid contains a massive amount of information, revealing all the secrets about the health of that machine. So what does this blood test show us? It's looking for three critical things. First, the health of the lubricant itself. Is it still good to go? Second, what are the contamination levels? Is there dirt or water or anything else in there? And third, machine wear. By looking for microscopic metal particles, it can tell you if a specific part, like a copper bearing, is starting to fail, long before you could ever possibly hear it or feel it.
So what happens when you put all of this together? When you make that shift from a reactive mindset to a truly proactive defense focused on precision lubrication? Well, the results, they're nothing short of astonishing.
Let's look at a real-world example from a steel mill. They implemented a top-notch contamination control strategy for their hydraulic systems. The result? An 80% drop in failures. Let me say that again, an 80% reduction. That is the incredible power of focusing on the tiny root cause.
And this isn't just a one-off thing. Study after study shows that a proactive maintenance program, one that's centered on keeping lubricants clean, cool, and dry, can extend the life of equipment by 2 to 5 times. We're not talking a small percentage here. We're talking about a multiplier. It's one of the highest return investments a company can possibly make.
So at the end of the day, the crucial takeaway is that by understanding this microscopic battle and shifting our focus from fixing big, expensive problems to preventing the tiny, invisible ones, we can get these unbelievable results. And it really illustrates a universal principle, which leaves us with one last thought. If this proactive approach is so transformative for machines, where else in our work, or heck, even in our lives, could focusing on the root cause make the biggest difference?